Hello, everyone. I'm Robert Haas. I work at EDB as VP Chief Database Scientist. I've been there for 14 years, otherwise known as since the dawn of time. And I'm a PostgreSQL committer and major contributor. And today I'm here to talk about how AutoVacuum goes wrong, mostly based on my experiences at EDB helping customers who are having actual problems with AutoVacuum. And the subtitle is, and can we please make it stop doing that? Because when I gave this talk before, it was a very user-oriented talk, like if you are having a problem with AutoVacuum, how do you fix it? But for this conference, I was asked if I could make it more developer-focused, like how could we, as PostgreSQL developers, make this system better? So I'm going to give my view on that. And there are plenty of people in this room who are more than qualified to disagree with my view on that. But I will be telling you what I think, and then you can all decide what you think. So I'm going to start by doing an overview of the major failure modes of AutoVacuum as I've experienced them. Then I'm going to talk about cost limits, which in my opinion is the elephant in the room in this area. Then I'm going to go through the different failure modes and talk a little bit more about each one. And then I have a couple of concluding slides. So let's talk about how vacuum and AutoVacuum fail. There are actually two different systems here, right? There's vacuum, which is an SQL command, which you can run anytime you want. And then there is AutoVacuum, which is a system for automatically running the vacuum command at times that it decides are good times to run it. And either one of those can go wrong in various ways. So one kind of failure mode is AutoVacuum is, or vacuum or AutoVacuum is slow. So there is a vacuum running on a table, and it is making some kind of forward progress, but not enough forward progress. And sometimes that means we need vacuum to finish in an hour, and it takes 3 hours. And sometimes that means we need vacuum to finish in an hour, and it takes 3 weeks. So that's all slow, okay? Then we can have AutoVacuum being stuck, so the vacuum is actually making no forward progress at all, and even if we give it until the heat death of the universe, not only will we not finish, but we'll be no farther along than we are right now. Then you have AutoVacuum spinning, where AutoVacuum repeatedly runs vacuum on the same table over and over and over again, and nothing gets any better. We have AutoVacuum skipped. So that means that AutoVacuum looks at the table and goes, yep, that seems fine, but actually it's not fine. And then finally, we have vacuum starvation, which is when AutoVacuum would be aware, if it looked at certain tables, that those tables need to be vacuumed, but it actually never looks at those tables because it's too busy doing other things. So those tables are starved. They are deprived of the opportunity to get AutoVacuumed. And I'd like you to all just note how cleverly I made all of these begin with the same letter. So please be aware. So with that very brief introduction, let's talk about cost limits. First of all, what are cost limits? We have the main setting here is AutoVacuum vacuum cost limit. There are a whole bunch of related settings, which I will not enumerate individually, but you can find them in postgresql.conf. They're spread across a couple of different sections because putting all of the related parameters in the same section didn't work out, but they're there. And basically the purpose of these settings is to prevent AutoVacuum from consuming too many system resources, which is in concept a good idea, but the problem with trying to prevent something from consuming too many resources is sometimes you prevent it from consuming enough resources, and then the work doesn't get done. And that's really, really bad. In the previous incarnation of the talk, I had some slides about why it's really, really bad if you don't vacuum your tables enough, and I have removed those for this audience, but I can refer you to another version of the talk where I go over that, but it's very bad if you don't get enough vacuuming done. And the fundamental problem here is that basically this set of parameters, principally AutoVacuum vacuum cost limit, is a soft cap on how much vacuuming work we're going to be able to do. But the actual amount of work that needs to be done is variable. It depends on the size of your database. it depends on the rate at which dead tuples are being created, and it depends on the rates at which you're consuming transaction IDs and multi-transaction IDs. And it's multiplicative. The size of the database gets multiplied by the rate at which dead tuples are created, and that is one measure of workload, and by your XID or MXID consumptions, which are other measures of the work that vacuum needs to be able to accomplish. But there's nothing in the way that the system is configured that takes any of that into account. So whatever value you have for auto vacuum vacuum cost limit in your configuration file, that's your limit for your database, and it has to be configured in a way that is appropriate to the size and busyness of the database that you have. And if it isn't, if it's too low, then you just don't get all of the vacuuming done. Cost limit problems, in my experience, are the single most frequent cause of the vacuum slow case and of the vacuum starvation case. And it isn't close. It's not like this is number one and there's a number two right behind it. It's like this is number one and number two is like a very distant second place. And one of the problems here is that users don't really understand what to do when they're having this problem. They have difficulty recognizing what's happening, but even if they do recognize what's happening, their first reaction is very often to raise auto vacuum max workers. And that doesn't work, because we take the cost limit budget and we spread it across however many workers you have. So when the user when the user is able to figure out that they have a shortage of vacuum resources and they try to fix that by adding workers, then all of the individual workers just go slower because there are more of them, and we still don't have enough resources mostly. I mean, there are some cases that some of you will be aware of where that will work, but it often doesn't, and it can even make the problem worse. The main thing that we have done that hugely improved things in this area was in version 12, we reduced the cost delay by a factor of 10. That's equivalent to increasing the cost limit by a factor of 10. And this, in my anecdotal experience, helped a ton. This went from being something where I was dealing with an angry customer like every week to where I deal with like an angry customer every couple of months who has this problem. So that change to me went a long way in the right direction, but it's still true that when people have this problem, it's probably because the cost limit is getting in the way of getting all of the work done. It just doesn't happen to as many people because now the default value is better suited to the hardware that people are actually running Postgres on these days. One other thing I want to mention about the cost limit is that we do have this emergency mode that vacuum can enter when things seem to be getting really desperate, and that one of the things that emergency mode does is it starts disregarding the cost limit so that vacuum just runs at the maximum possible speed. But that kind of happens too late, because by the time emergency mode engages, your database is in danger of ceasing to accept write transactions because you've consumed so many transaction IDs without properly vacuuming everything. And by the time that happens, your tables have probably all bloated really, really badly, and your database performance probably sucks a lot, and you're probably going to have to do painful things like run vacuum full in order to get the system back into a good state. So the idea is good, and certainly preventing full exhaustion of XIDs is very good, but it doesn't really happen soon enough to keep users from experiencing this as like a pain point. Because it only kicks in like at a level of desperation where things have kind of already gone downhill extremely badly. So how can we think about what problem we're trying to solve here? I think it's useful to think about the idea of vacuum's backlog. So if we imagine as a theoretical concept, the set of all tables in all databases in the PostgreSQL cluster, which vacuum would want to vacuum if it looked at them, right? And we imagine that set as it exists at any moment in time, and it's constantly changing, because as the table statistics change and system activity happens and the various counters move forward, the set of tables that are eligible for a vacuum from auto vacuum will constantly be changing. But we can think about what that set is at any given point in time. It's a well-defined set, and we can imagine it growing and shrinking. And I think our intuition should be, if that backlog, that set of things that would qualify for a vacuum if we looked at them, if that set is growing, then we don't have enough cost limit. And maybe we also don't have enough workers as a sort of secondary problem. I think that's a good starting intuition, but I don't think it quite gets us where we want to be, because by the time the backlog starts growing, we're already kind of on the back foot, right? If we noticed when this backlog was growing, if we had the ability to notice when this backlog is growing, that would be reactive. But we'd really like to be proactive. We'd like to get ahead of the problem and realize that the direction things are heading is not good, and we're about to see the backlog start growing in size, and do something before we get to that point. So if I were to sketch out a solution to this problem with a lot of generous hand-waving, imagine if we had a new set of auto-vacuum workers, perhaps separate from the set that we have today, that connected to each database and gather a bunch of information about what the state of things in that database is. What tables are already due to be vacuumed, and then for the other tables, estimate when they're going to need to be vacuumed. If the number of dead tuples is growing, we can maybe make a prediction of when it's going to hit the threshold. If XIDs are being consumed, and usually they are, we can predict how much time it's going to take before that table is going to hit the wraparound thresholds and become eligible for vacuuming on the basis of XID or MXID consumption. So if we did that, and if we also estimated how long each table would take to vacuum when we actually processed it, then we would have enough data, I believe, to do things like raise the cost limit or raise the worker count or both to try to bring the situation under control. And we could even do forward-looking things. We could say, well, the backlog is small now, but I can see that in 2 hours, it's about to shoot way up because a whole bunch of tables are all going to become eligible to be vacuumed at about the same time, and therefore maybe we have to get started on some of that work now. Or maybe not. There's a lot of hand-waving in this solution sketch, but I think in concept the idea is probably somewhat reasonable. Now, the same information could also be used for prioritization, because if we knew what tables were already eligible to be vacuumed and how long it was going to be before tables became eligible to be vacuumed, we could also look back, right? We could say, wow, this table has been eligible for a vacuum for a really long time already, and maybe that means it's a higher priority than some other table that only just crossed the thresholds. Or there are various other ways that we could use this information. But the point is, if we had some global state about the system, if we knew what was happening in all of our databases at any given moment in time, and we knew how far behind we were, then we could try to do the more important vacuums first. We could try to come up with a set of rules that says, this table is bad, but this table over here, whoo, that one's really bad, so let's do that one first. And I used to think that this was the most important problem in this area, this prioritization problem, but I've kind of changed my thinking because I believe I was wrong. I think prioritization is actually significantly less important than cost limit adjustment, because actually we really need to do all of the vacuuming that we need to do, right? If it's okay to just keep postponing some vacuum operation off into the future, that vacuum operation is kind of optional. And maybe we just shouldn't do it and should save the system resources that it would take to vacuum that table. I think it's kind of misleading to think that we may have situations where we need to vacuum a table if we have the resources, but maybe we don't actually need to do it if we don't have the resources. I mean, maybe that case exists, and maybe further research will sort of pin down, or actual research rather than hand-waving, will pin down in exactly what cases that occurs. But I think in general, it's mostly the case that tables either need to be vacuumed or don't. So I don't think I don't think prioritization is a bad idea, because it does seem like a good plan to do the most urgent tasks first. But I think the real killer is the cost limit adjustment, because What actually matters is that we make sure that we get all of the critical work done. The order probably matters, but I think probably less than just actually making sure we get to everything that is critical. So now I'm going to go into more detail on some of the individual failure modes. The first two cases I want to talk about are the slow and stuck cases. Why do these cases happen? Sometimes people think there's a problem when there really isn't. Like, they say vacuum is slow because it's been running for 5 minutes and the table is a terabyte and it's fine, right? There's no actual problem there. Cost limit too low is by far the leading cause when there is an actual problem. The other cases that I've run into with some regularity are waiting for some other PostgreSQL process, a slow disk, and corrupted indexes. Because we traverse the table in physical order, but indexes in logical order. So if the index, which is supposed to be in logical order, actually contains a circularity because it is corrupt, then we can go around and around and around and around and around and around and never finish vacuuming that index, which is not a ton of fun. The waiting for other PostgreSQL processes case has become quite uncommon in recent releases. Years ago, this was a giant problem. Like, it happened to everybody all the time for all kinds of reasons. And most of the easy cases and common cases have now been fixed. So this can still occur, and one example is if there's a cursor that is doing an index scan and that cursor is suspended, but the index scan holds a pin on some index page, then vacuum can get to that index page and be like, oops, I can't do anything until somebody moves that cursor out of my way, and that is sad. But that's a relatively uncommon pattern. There used to be much more likely things that could occur that would result in vacuum getting stuck. Doesn't happen very much anymore, and I think it's not really clear what we could actually fix in the code, because basically the remedy would probably have to be kill the other process to get it out of the way so that the vacuum can proceed and not be stuck. But that sounds kind of scary for various reasons, one of which is that users don't really like the fact that we have background processes doing a lot of work, and I think they might like it even less if the background processes started killing their foreground tasks. So it's not very clear to me how we can make useful progress on this problem. But the good news is that since it isn't super common anymore, maybe it's not critical that we do that. Slow disks, again, there's not a lot we can do. Sometimes this is simply a disk that isn't spec'd for the hardware, but it's also reasonably common that your disk is about to fail. And the first way that you realize that your disk is about to fail is that the I/O gets really slow. And the thing that's doing a lot of I/O is vacuum, so then you call EDB and you're like, hey, vacuum is really, really slow. And we're like, bad news. We cannot fix this problem for you in software. You're going to have to replace that drive. So that does happen. I don't think there's anything much we can do about that in Postgres. Corrupted indexes are kind of an interesting case. It's relatively rare, but I've seen it happen. The user level fix is either to drop that index or to re-index it. How could we do better, I think, is a little unclear. Maybe we could detect it automatically somehow and error out, but that seems to be not a trivial thing to do. And even if you did it, well, that would just result in the spinning behavior, right? Because if AutoVacuum thinks that the table meets the criteria for vacuuming and you kill off the vacuum process, AutoVacuum is going to come back to that table in like a minute, be like, hey, this table still needs to be vacuumed, and it's going to launch vacuum and go right around again and get back to the exact same place. Yes, Greg?
That is exactly what I've seen happen, where vacuum crashed on a given index. And AutoVacuum would immediately relaunch that same vacuum, which resulted in everything else getting starved of vacuum.
Yeah.
What kind of indexes would this happen on? Because as far as I know, B-trees is as well.
B-tree is the only case I've seen.
Okay.
B-tree is the only case I've seen. Mostly, I suspect, because customers don't actually use the other index types all that much. I mean, I actually don't know the other index types to know well enough to know off the top of my head to what degree they can contain circularities. But if you think about a B-tree index, we basically sort all of the data and have a bunch of next pointers, and there's nothing theoretical to prevent those next pointers from going in a loop. And if they do, it's not fun.
Is sequentially through the pages, and only if it's a concurrent split back to an earlier page, we go back to follow that link.
I don't think that's true. But the thing I know, the thing I know for sure is this happened, so therefore it is possible for it to happen. I'm very happy to discuss after the session exactly what might have gone into that. I was under the impression we followed next page pointers, but whether we do or not, it occurred.
I think the basic scan is sequential. We changed that years ago for performance reasons. But I would not be surprised if there are special cases like trying to remove an index page and free it up. You have to delete the up pointers, and there are probably scenarios there.
Yeah, it's occurred. So, but that's interesting. I guess my understanding of how we do this is not completely correct. So I'll have to improve my knowledge in that area. Okay, so let's talk about spinning. Here again, occasionally users get confused, and I think there's a problem when there's not, right? If you are seeing a lot of vacuum activity on a table, it could just be that you have a lot of write activity on the table, and so by the time you get done vacuuming, it's ready to be vacuumed again, and you just keep doing it. But if that's not the case, then you generally have one of two things. You either have vacuum failing with an error and auto vacuum retrying it, or vacuum and auto vacuum don't agree on whether it's time to vacuum this table. And auto vacuum thinks that the answer is yes, and vacuum thinks the answer is no. So what happens in that case is that auto vacuum keeps launching vacuum operations. The vacuum operation says, looks fine to me, and auto vacuum says, nope, let's go again. And they just keep doing that. I have found that vacuum failing with an error, in my experience, is surprisingly uncommon. And I say surprisingly because vacuum is a relatively complicated operation that seems to have lots of things that could hypothetically fail. If, for example, we can't read a block off of the disk, we're going to fail trying to bring it into the buffer cache. But I have found that this error looping behavior, maybe those cases happen and they just don't get to me because it's more obvious what has gone wrong, but I don't actually often see this case in the wild. Yes, Andres?
One very common case that you have like some DDL command that gets run on a common basis, on a regular basis into the Trappist vacuum because we cancel all the vacuums whenever there's a conflicting lock. And I've seen that in hundreds of other cases. Okay,
yeah, so Andres is talking about the case where we cancel a vacuum due to a conflicting lock and then end up having to retry it, and that happens repeatedly, which that does sound like a thing that could happen. But what I have found, again, experience may differ, but what I have found to be the most common case here is what I call useless vacuuming, where something is holding back X-min, which means that the old tuples in the table are not actually dead, because there is still some hypothetical possibility of those tuples being visible to some transaction or something, and so we can't actually remove them. And so auto vacuum is like, there's a lot of deleted tuples in this table. And vacuum is like, yeah, I know, but what do you want me to do? And vacuum is like, there's a lot of dead tuples in this table. And vacuum is like, yeah, sorry. And they just keep going around like this, and you burn a lot of system resources, which can then cause starvation on other tables, because you're so busy doing useless vacuuming on the one table that other tables aren't even getting the attention that they deserve. But even if there's no starvation happening and you're just wasting a lot of resources that you can spare, it's still not nice to waste a lot of resources doing something that isn't really helping. And there's kind of three subcategories of this. There's long-running transactions, which will show up in PG stat activity, and they need to be killed so that X-min can advance. Unused replication slots, typically because somebody got rid of a standby and forgot to delete the replication slot that standby was using, and so then that slot just sits there and holds back X-min forever, or prepared transactions that haven't been cleaned up. So generally, this is relatively easy to fix, which is the good news, because typically you have one of these three. I have seen a few reports which seem to imply that there might be some mysterious fourth thing that could cause this, which I haven't been able to quite track down, but usually it's one of these three, and when you find the offending slot, prepared transaction, or transaction, you kill it, and things get back to normal. But it would be nice to do better, and I think the dumbest possible fix would just be to keep track of whether we did anything when we vacuumed the table. And if we did exactly nothing, then don't do it again until Xmin advances, so that we don't keep vacuuming the table over and over and keep doing nothing. There are several, I think, fairly obvious problems with this, one of which is that we're still going to do at least one useless vacuum, right? And also, like, even if Xmin advances, there's no guarantee that that does anything useful. So it could be, for example, that the current Xmin of the system is 1 million, and all of the deleted or updated tuples in the table, all the old tuples in the table, have a Xmax of 2 million. And then we need, in order to be able to remove those, we need the system-wide Xmin to advance up to 2 million or past 2 million. But it could advance, hypothetically, one XID at a time. So it could go 1 million, 1,000,001, 1,000,002, 1,000,003, and we vacuum each time, and we have to get all the way to 2 million in the worst case, counting one by one before we actually do the vacuum that fixes anything. I mean, in practice, we're vanishingly unlikely to get that scenario because that's not the way that people actually write applications. User applications don't ever behave in ways that are that pathological in practice, but there's at least some possibility of wasting a lot of resources here because Xmin could advance, but not by enough to matter. And also, even if vacuuming is not totally useless, it could still be mostly useless, right? Because we could have a billion dead tuples in the table, and Xmin could advance, and that could allow us to remove 3 of them. And then we could vacuum the table to get rid of those 3. And then that situation could repeat any number of times, which would result in very little useless vacuuming, but an awful lot of almost useless vacuuming, which would be not ideal. The question we really want to answer, if we wanted to fix this in a smarter way, is what is the next currently non-vacuumable XID such that when that XID does become vacuumable, we'll be able to clean up a reasonable number of tuples, right? So we'd like to say, here's where Xmin is now. If it got to here, that would allow us to clean up enough stuff that it would be worth doing. And I have a feeling that there might be somebody in this room or in the Postgres community who is better at math than I am and can come up with a really clever data structure that we could feed information about the tuples into this data structure and an answer would pop out that had a really good chance of being correct. But I don't think that the simple solutions that I can easily think of are quite as good as what I would like to see. Because, like, you can break up the XID space into ranges, buckets essentially, and count the number of Xmaxes that appear in each bucket, and so you get a sense of how the dying tuples in the table are distributed across the XID space, but it's pretty approximate, and a lot will depend on how well you choose those buckets. So a simple example is if you bucket together XIDs 1,001 through 2,000, you won't think it's time to vacuum the table until the system when Xmin crosses 2,000. But it might be that all of the tuples in that bucket are actually at 1,001. They're all very near the beginning of the bucket, and so you could have actually vacuumed potentially much sooner. Because the important thing to understand here is that our movement through the XID space is very non-uniform, right? Like you can have the same system-wide Xmin stick around for a long time, and then it can abruptly jump forward either by a small amount or by a large amount. And it's very difficult to protect what will happen in any particular workload. So therefore, it's hard. It's not great to be wrong here by even relatively small numbers of XIDs, because potentially being off by 1,000 XIDs in this calculation could result in hours of delay in vacuuming the table, which would be not great. Okay, so what about the starved and skipped cases? In these cases, what the user sees is that auto vacuum is not running vacuum on my table, and they wonder, like, why is that happening? And basically, if it's starved, then the reason why that's happening is because all of the auto vacuum worker processes have been busy doing other things, and so they haven't gotten around to looking at your table and deciding, oh yeah, this one needs to be vacuumed too. On the other hand, you also have the skipped case, which is where auto vacuum looks at the table and says, yep, everything here is fine, when in reality, everything here is not actually fine. I have found that the easiest way to distinguish these cases as a support professional is to just look at pgstat activity and look at how many auto vacuum workers have been running and for how long. Because if I see that auto vacuum max workers is set to the default value of 3, and there are currently 3 auto vacuum workers running, and they all started 16 hours ago, well, it's starvation, right? Because all of the auto vacuum workers have been running flat out for hours and hours and hours. The reason this table isn't being considered is almost certainly that we just don't have enough resources to get to that. Whereas if they've been running for like 5 minutes, then the table's probably skipped, because we probably thought it didn't need auto vacuuming, otherwise we would have done it. Starvation is caused by what we already talked about. The cost limit is too low, or you need more workers. Skipped is more interesting. A pretty common cause of this, in my experience, is misconfiguration. The most blatant form of misconfiguration is that someone, at some point, intentionally turned vacuuming off on that table. They said auto vacuuming equals false, and then that person forgot that they did it, or left the building, whatever happened, the institutional memory was lost, and eventually it becomes a problem because the table is not getting vacuumed. And there are subtler ways that you can accomplish the same thing by tweaking other auto vacuum parameters on the table, but I found that this is pretty common. There's not a whole lot I think we can do about this in the code, but I have found it to be a pretty frequent cause of this issue. Second fairly common cause is people just blowing away their statistics, and then we just don't know anymore. Because a lot of people seem to think that pgstat reset is just a fun thing to do to your database from time to time, and they don't realize it's actually removing extremely critical information without which auto vacuum is going to do the wrong thing and you're going to be sad. So maybe we need to improve the documentation or do something to this function to discourage people from using it, or I'm not sure what exactly. But clearly there is some confusion floating around out there over why it's bad to just reset your stats. And I think some people do it for reasons as simple as, well, I want to see how fast the counters are climbing, so if I just reset all the counters to 0, then I can look at the current values of them again after some time, and I won't have to subtract anything, because it was 0 to start with. And they don't realize that auto vacuum is also looking at those counters and might mind if you just threw away all of the data. The other cause for this that I've seen that we might be able to do something about in code is very large tables. The scale factor system that we have simply doesn't scale. It doesn't work the way we need it to for very large tables. And I think there's a couple of reasons for that. I mean, the way the scale factor system works is we take the scale factor, which is by default 0.2, and we multiply it by how many tuples we think are in the table, and then we see whether we've got updated or deleted tuples that exceed that number. But 20% of the table size gets really, really big when your table is really, really big. If your table is 10 megabytes, 20% of it is 2 megabytes, that's fine. If your table is 10 terabytes, 20% of that is 2 terabytes. That's too long to wait. You don't want to wait until you have 2 terabytes of crap in your table before you start trying to get rid of the crap. I think one reason why that is the case is because of multiple index passes, which is something that happens when you have very, very large number of dead TIDs to clean up, and that should be helped by the new TID store, which is more memory efficient and can fit more dead TIDs into the memory that we have. But I have a feeling that's not going to get rid of this problem completely, because I think that waiting until we've got terabytes of bloat in the table before we start to take some action is just not the right idea. I would appreciate the experience of other people here to try to formulate this idea more precisely and pin down exactly why that's a bad idea. My empirical experience is that it does not work out well for you at all, but I'm not sure that I'm totally able to articulate the exact mathematical reason why it's like that. I just kind of know it's like that. So I think we need to somehow either cap the result of the scale factor calculation or grow sublinearly. as the table size gets bigger or something like that, because right now we can just wait ridiculous amounts of time before we trigger vacuuming on a very large table, and that's no fun. Okay, I have two concluding slides here. One of them is an idea that I haven't really had a chance to mention explicitly earlier, although I did allude to it at a few points. But I think this is actually a very important shortcoming of the current system. Auto vacuum is a trigger-based system, not a goal-based system. So your goal as a human being is for auto vacuum to keep your system working properly. But that's not auto vacuum's goal. Auto vacuum's goal is to start doing things when configured thresholds are met. So it cares about when things start happening, but you, as the user, care about when things finish happening. Because it's really only when vacuum finishes that you get a benefit. You don't get much benefit from an ongoing vacuum that has not yet completed. And when the tables get big, the discrepancy between those two things becomes large. Like for small tables that are going to take a minute to vacuum, whatever, like the fact that we're timing when the operation starts versus when the operation finishes really doesn't make any difference because they're going to happen quite close together in time. But as the tables become larger and larger, and in particular, as the indexes on those tables become larger and larger, and remember, we can't skip index work the way we can skip table work, because we can skip table work using the visibility map, but we cannot skip reading any part of any index. So vacuuming involves reading every index on the table in its entirety every time we need to clean out dead TIDs. And if you've got 10 indexes on a 10 terabyte table, that is a lot of index data that has to be read for every vacuum operation. So the vacuum takes a long time, especially with the cost limit as an aggravating factor. And so the difference between when we start and when we finish becomes very material. And one way that we see this in our default settings is that we have a very conservative value of auto vacuum freeze max age. We set it to like 300 million by default, I believe. The hard limit is actually 2 billion, but we have to set a very low limit by default because we don't know how long the vacuum is going to take. We can't say this table is 5 megabytes, so it's fine to postpone vacuuming it for wraparound for a really long time, because it might equally well be a 5 terabyte table, which is going to take forever to vacuum, and we don't know that. So we're applying this uniform limit to a table that might be very large or very small, and therefore the limit has to be conservative in case it actually is a very big table. I think this effect might also be part of why the scale factor doesn't work well on large tables, because if you start vacuuming a giant table when you've already got 20% bloat, by the time the vacuum finishes, you're going to have overrun that 20% threshold by a larger margin than you will on a smaller table where the vacuum completes quickly. I think we're going to find if we try to do prioritization that this discrepancy also interferes with reasonable algorithms for doing prioritization. So I suspect something needs to be done about this. So to summarize the improvement ideas that I've presented in this talk, where I have done no work and only told all of you what you should maybe think about going out and coding, or maybe I'll go out and code some of it, but I'm just throwing out ideas here that may be worth discussing and may be worth implementing. First idea, I think by far the most important, is to automatically tune the cost limit and secondarily the worker account in response to how much pressure the system is under. Second idea is maybe also piggyback on that same infrastructure to do prioritization. Third idea is to avoid useless vacuuming when something is holding back Xmin, method to be discussed. Fourth idea, which I think is probably actually relatively simple, although somewhat less important, is to rethink the scale factor mechanism for really large tables. And the fifth idea is to move the system toward being more goal-based rather than being trigger-based. I know that this talk has probably gone over the heads of some people in this room who are not PostgreSQL hackers. I've tried to make it accessible, but I'm sorry if this has all gotten down too far into the nuts and bolts for you to follow. But I hope that you learned something from it, and I hope that, especially if you are a hacker, you either think that these ideas are good or that you think they are bad for some reasons that you can tell me about. So that I can improve them, or we can do whatever we need to do. Because I do think that this is a pretty significant operational problem with running large Postgres databases today, especially large busy Postgres databases. And I think that improving it would really help a lot of people, especially people who have tons of really big databases. So that's it. Thank you very much. And in the time remaining, I can take some questions.
If you have a load with idle time where there's not as much activity, where would scheduled manual vacuums fit into this?
Yeah, so that's another improvement idea which I didn't include in this talk. I mean, in theory, you could have something built into the system where you tell the system where your down periods are, and it automatically does that. But I think it's also not too unreasonable to just do that out of cron, right? Like if you have
That's what we do.
Yeah, if you have a lower usage period, maybe lower your limits during that period of time, vacuum with a lower vacuum freeze table age and vacuum freeze min age. Maybe don't lower them all the way down to 0, but a lower value, manually run a vacuum during your lower usage period, and you can kind of get ahead of some of the work that's going to happen in your busy period. Yeah.
So I'm curious how you would figure out how to do with a bursty database, right? And you're going to have lots of work at random times. How would you get to that preemptive, forward-looking, goal-based achievements?
Yeah, that's a really good question, and I think to some extent that is a research problem. But my intuition is that if you find, so for example, if you measure the rate of XID advancement, right? That is going to be fast during some parts of the day and slow during other parts of the day if you have a bursty workload. But my idea, just off the top of my head, would be maybe something like measure that in every 1 hour window throughout the day, and then to take the highest of those 24 numbers and assume that's the rate. So it's like not like a radically worst case rate, but it's like somewhat worst case rate, right? Like to have something that's more conservative, that's at least as conservative as what's probably actually going to happen. Yeah, take the history and squint at it is a good way of putting it, yes.
So right now we have parallelism with vacuum command. Do you think that if we somehow try to involve parallel workers with auto vacuum, also will it help in some way to move?
Yeah, so I
into
think the
goal-based
problem
thing?
with trying to do that right now is that the infrastructure that we have is so primitive that it would be very difficult to make good decisions. I think it's sort of the same problem with prioritization. We have no global state right now. We have no knowledge of what's going on throughout the system. So it's hard to decide, would it be worth devoting 2 workers to this particular vacuum to speed this one up at the cost of one of those workers now not being available for some other operation? Right now, I don't think we have enough information to make a sensible decision about that. But if we gathered the information we needed to tune the cost limit, prioritization would be one application of that, and deciding on degrees of parallelism, I think, could be another use for that same information. Yeah.
I have one comment and one question. So I get intrigued earlier and say, hey, the mathematical model, because the large table, the scale factor, right? You talk about that one. Been thinking about this one as well. So I think you can build a math model. Basically says for every garbage you introduce, right, it's a fixed cost to clean it up, right? So and then your machine has limited resources, right? Because it's capped. So it's not a scale factor because it's not about percentage. It's really now you have an upper limit, and every garbage, how much it costs, that your machine is too low for that, right? So you could get a mathematical model to say, hey, once my table or once my the garbage is higher than a certain level, the scale factor doesn't matter because I'm already blowing my limit, right? Because your machine doesn't scale as your garbage scale. So that's going on just for thought. But I have another question. Actually, is in our experience, we have a lot of XID issue because customers do have they have I think you mentioned what is it the disabled the replication slot. And we're concerned about killing them just on behalf of the customer because it may entail data loss. I just wonder if that concern what do you guys do?
Right. Well, I mean, I think you can't run replication that doesn't keep up. Like, it would be nice if Postgres had an architecture that could support that, but we don't. So ultimately, you're going to have to choose between replication that keeps up and not replication. You're going to have to go one way or the other with that.
All right, I agree with that. Have you guys ever thought about just automatically killing these kind of inactive
We
slots?
might even have an option for that now. I think it's certainly been proposed. There's what?
Okay.
Yeah.
Because we internally also debated that, but we're just cautious because of data loss. But
Yeah, I mean, I think this is taking us too far afield from the topic of the presentation. I think, like, managing replication slots presents various challenges, and there are a number of things that we could do, I believe, to make replication better, but, like, so there's a step or two removed from the problem that I'm mainly worried about here. Yeah. Melanie has a question if we, okay.
Oh, sure. So my question is regarding the large tables with, auto vacuum stuff. So we have a similar situation in our company as well, where like there are like a lot of larger tables taking longer time, to finish those auto vacuum processes. Now I understand we can have like scale factor and things like that in place to be more proactive than reactive. But now, by the time we realize that we already crossed the threshold, now we are in the situation where auto vacuum is like keep running for hours and hours. So how we can rectify that, in order to become a product, going forward?
Yeah, so I think that question has a longer answer than I can give right now. Like, one of the things that I think is a real shame is that most of the Postgres monitoring tools that I have run into over the years do not have queries built into them that seem to be designed to tell you when you're getting into auto vacuum related trouble. And some of the queries that I have seen that aim to do that in ways which I think may not actually be quite capturing the stuff that we really care about. So I think we need to have better monitoring tools as a community out there that will help people understand when they're getting into trouble before they hit the wall. But in terms of answering the question of how can you, with the things that are available today, fix your problems, that is a much longer answer than I can give you right now. So, EDB support conversation or whatever, but like that's a whole presentation all by itself. Yeah.
The scale factor stuff you were talking about, if you've got a multi-terabyte table and the amount of, it has to wait until there's a really large number of dead tuples. Why would you ever want that number to, the absolute number to be more than you could fit in the TID store?
Well, you wouldn't, but what I've been told is that the TID store limit has gone from 1/6 of a billion to effectively infinite in the forthcoming release. And if that is true, then that's not a useful limit because like capping it at below infinity is not good enough.
But it respects a setting still, doesn't it?
Yeah, but it's what I have been told. I haven't looked at the code, but what I've been told is that the new thing is so memory efficient that we never run out of memory, right? Yeah. So like, if we had talked about this problem in this level of detail 5 years ago, we might have decided to cap it at the point where we hit the index scan limit, but then this TID store work would have reintroduced breakage that we had fixed, because that turns out to be somewhat accidental to the problem that we really need to fix.
I see.
Yeah, I think that's making an interesting point that we should be careful about working around problems in auto vacuum that are really problems that should be fixed at a lower level, and when they are, all that work on auto vacuum might be wasted. Like, for example, if we had done work focused on avoiding multiple index scans and then we fix vacuum so that it doesn't need to do those multiple index scans, it was misdirected work.
I think that is a fair point, but I also think that auto vacuum is more to blame than vacuum is. Like, I think, and I don't think that was necessarily always true. And there's also some fuzziness about which things fall on which sides of the line in some cases. I think at this point, my feeling fairly strongly is that, yeah, there are some problems on the vacuum side, but a lot of those problems are kind of like intrinsic to what we're trying to do, or a lot of the auto vacuum problems are kind of caused by this infrastructure having been invented in like 8.2 and been slightly upgraded since then.
So, like, rather than focus on the multiple index scans, I think the root of the problem with the scaling, like you're describing, is the 20% makes a lot of sense as long as you start from a certain set of assumptions, which is that your table, your entire table is uniformly used in a similar way. But what a lot of people actually have is a terabyte table where 100 megabytes of it is busy. And then you want to vacuum when that 100 megabytes is 20% dead tuples, not when the terabyte is.
Yeah, I think there's some truth to that. I think, not sure that's the whole kit and caboodle, but that is probably one of the aggravating factors.
One thing that I had an outsized success with at a previous, well, we had an outsized success with at a previous employment was a daily cron job that changed the scale factor based within a range, based on metrics. It looked at the number of auto vacuum jobs that were running on average at any given time. So it looked at the previous day's average number of jobs and aimed to have an average of one job running all the time. Because if you have more than one job running, you're not going to get any more progress. You're just splitting the work across multiple jobs. And if you have less, you're not spreading, your cost delay can be, and it adjusted the cost delay, not the threshold. So the idea was slow down the work only as much as you can without causing things to start backing up.
I think the concept is reasonable. I think there's a bunch of details to quibble with in there. In particular, I don't think that adjusting the scale factor is the right way to control how aggressively we vacuum.
Sorry, it was the cost delay. Sorry.
Adjusting the cost delay is a much better way of controlling how fast we vacuum, although I still think the limit is better than the delay.
So the idea was, and then what would happen is the busier customers would have a lower cost delay, but they would also have better hardware. The customers that had, I say customers, but anyways, the databases that had a problem of some sort, it would eventually adjust the cost delay up to a problematic level.
Early in the talk, you suggested formulating the control algorithm for this as being responsive to the rate of change of the backlog, which...
That was more of an intuition than an exact proposal, because I don't think that's right in detail.
Yeah.
And I bet you're about to tell me why, which is cool and everything, but I do know it's not quite right.
I see one failure mode in it, which is when your back is to the wall because every single table needs vacuuming. The backlog is capped, right? It's 100%, it's not going up. And if your algorithm says, steady backlog, I'm in great shape, then you have a problem.
Right. So I think actually probably a better way to say it is like we want to try to keep the backlog small. So if the backlog is getting big, that's a problem. And if the backlog is about to get big, that's a problem. So I think it's probably more the size than the first derivative that is what we care about, but even that I'm not sure is quite the right concept.
Yeah, I'm not sure either, but I think rate of change is probably not the right way to think about it.
Accepted.
I think on the first slide, you had a suggestion for how to get some of the information that you would need to make decisions about when you thought the table would need vacuuming, and you're saying having a bunch of workers that would go and collect that information. And I wondered if you felt strongly about doing this sort of like, because you could hypothetically do something on update or delete about measuring bloat, but, and other ways of getting the information that you might need, not by because it seems like it would be complex to come up with another system for managing when those other background processes should go and get that information, and that's like its own sub-project that I imagine has algorithms and work. And
so the reason why I suggested doing it that way is because it is the easiest way that I can think of to make sure that we actually get updated information about every table on a regular basis. If we try to drive it off of the workload, then tables that don't get touched, their information doesn't get updated, and I think there are going to be problems there that I'm not sure that we can solve. but it's probably a longer conversation that we should have not in this meeting. Like, this is all very hand wavy, and I like totally appreciate everybody's engagement, but like, we definitely cannot design this by Q&A at the end of this presentation. So we will have to talk about it, you know, in the hallway and whatever, and try to figure out some design ideas that will work. It would be cool if we could drive it all off of foreground activity, but my feeling is that's maybe going to have issues with the amount of cost that those updates impose and maybe the completeness. And I don't actually think having a pool of background workers is that big of a deal anymore, because lots of people have written extensions that do this background pool of workers thing, right? Like everybody, it's like a rite of passage for a PostgreSQL developer to write a thing that drives a pool of background workers, one per database, because we can't have cross-database connections. And once you've crossed that chasm by fire, you can say, okay, now I'm a grown-up PostgreSQL hacker. Like so many people have had to do this task for various different purposes. And it's sort of a shame that we don't have some better way to handle it in general, but like, I don't think doing one more is a huge deal, but on the other hand, if there's a better way of doing it that doesn't involve having to make one more thing that iterates through all of the databases, like, awesome, I would love that. I don't immediately see how to make it work, but that doesn't mean there isn't a way to make it work, so.
I did notice that an item, well, not necessarily missing, but when an auto vacuum is cancelled because of a concurrent lock that would be acquired, why don't we store the current state and continue on starting from there?
Because it's hard.
I think there's some problems with actually correctly knowing how to determine the correct rel for the next ID after you restart. It's not unsolvable, but it's not trivial.
I mean, if you could hold on to the dead TIDs from one vacuum to the next, this would all become a lot easier. And I actually tried working with Dilip to implement something like that, and we kind of got stuck in the weeds a little bit. Maybe there's a way to salvage that effort, but now the new dead TID store maybe makes that effort obsolete. So I don't know, we have to think through that and try to figure out, like, I don't think the idea of being able to resume vacuum after a pause is a bad one, but I do think, like, it's not trivial because there's this large piece of state that you have to carry around in order to be able to do it effectively. I think it could have significant other benefits besides this project. But the other thing that I'm sort of realizing about this is, like, even if vacuum could do all kinds of cool things that it can't do today, if auto vacuum is like, duh, and is really, really dumb, it's not gonna matter how many cool features vacuum has, because auto vacuum isn't gonna be able to make intelligent decisions on when to be able to make use of those features. So I could be wrong, but I'm starting to lean more in the direction of thinking that we need to clean up auto vacuums a bit and make it smarter and make it more stateful, so that then, like right now, if Amit wanted to do his project of making parallel vacuum used by auto vacuum workers, he would have a very big job to do, right? But if we had some better infrastructure where we knew what was going on, then he could probably write a relatively simple patch on top of that to take that particular consideration into effect. So I think, like, these ideas for improving vacuum conceptually, parallelism, resumption, various other ideas that we might have are pretty good, but I also think that we probably are getting to the point where it's going to be hard to make use of them without improving the auto vacuum smarts itself.
Yeah, I agree with that. I had one other comment, which is that one problem with just resuming a vacuum is that by the time you get around to doing that, very possibly Xmin has moved forward, and you would be better off, doing a fresh
That's another
scan.
consideration, yeah. I have noticed that it is time to eat lunch. And I would like to say that as much as I appreciate all of you coming to my talk, the priority of lunch is higher than the priority of all auto vacuum related things. So thanks everyone for the questions, and we can chat.